Okay, so if you guys remember, we looked at these two equations in the first part. X at t equals x naught plus v, or velocity over Coriolis force, times sine, and then in parentheses, so all of it is Coriolis force times time minus phi naught plus sine phi naught, and then plus UGT. Alright, so first you might be wondering, what is this phi naught is? Let's take a look at it. If you guys remember, phi naught, if we break velocity up into its u and v components, this is phi naught, right? So that was just an arbitrary one, but as it turns out, our velocity starts in the north direction. So all we have, as you can see here, is a VG. We're only given, all we have is a V equals 0.6 meters per second. We're only given, initially, a northern velocity. So our initial phi naught is this angle, which is phi naught equals 90 degrees, but we're going to want to use it in radians, so let's say pi over 2. Alright, now, based on everything we talked about in the last video, we should be armed to do this. So let's do x component first. So, looking at that equation, I'm going to write it right here. X at t equals, okay, so x naught, x t equals x naught. Well, we're looking at displacement, so that's just going to be 0. So I'm going to say 0 plus v, and we already had the initial velocity of particles directed northward as an amplitude of 0.6 meters per second. And forgive me, I'm just going to drop units, but once you multiply it all out, it'll just be in meters, okay? So then we're also given f equals 10 to the negative 4 inverse seconds. That's actually going to also drastically change things, so we'll just treat f as a constant, because he told us to. 10 to the negative 4. Okay, multiply that entire thing by sine, and then the sine function is going to be of, again, Coriolis force, which is 10 to the negative 4, multiplied by time, and he gives us time. It's 3.5 inertial periods, which is 7 pi over Coriolis force, which is 10 to the negative 4. Oops, nice, there we go. Bam. Okay, and then minus phi naught, which is 90 degrees, or pi over 2. Okay, now it's same thing. We're still in the brackets, keep in mind, still in the brackets, so we're multiplying everything by v over f. So plus sine pi over 2. Now close your brackets. Now plus UGT. And all we have is a VG component of velocity going northward for geostrophic, and we're also told the steady geostrophic component of the flow is also northward and has an amplitude of VG equals 0.1. So UG 0. Boom. All right. YT. YT. Again, we have y naught equals 0 plus, again, v 0.6 divided by 10 to the negative 4. Why was that? Because it's velocity amplitude divided by Coriolis force. Now this time it's very similar, but instead of sines we're using cosines. So for the same exact reasons I used in the sine argument, it's the same, except I'm just now doing it with a cosine instead of a sine. So that's why I am just writing it. Hopefully that is good to go. Plus, or excuse me, not plus, according to the equation, it's a minus unless I miswrote it. So, hopefully I didn't miswrite it. And I brought it over here. Cosine, again, phi naught pi over 2, plus VG, which we actually have, which is 0.1 times time, which is 7 pi over 10 to the negative 4. And that should also give you meters. Okay. So that pretty much does it. You can just go ahead and calculate that out yourself.